So moving away from marine and offshore structures towards more terrestrial ones, we now look at two codes that came out at the turn of the 90s and early 2000s. The Joint Committee on Structural Safety Probabilistic Model Code and the 1998 revision of ISO 2394 General Principles on Reliability of Structures. So there are certain interesting features, and we will identify them one by one. The importance of consequence of failure is still there in this code. For example, here in the ultimate limit state, we see there are three levels of consequences: minor, moderate, and large. And the codes have defined, actually JCSS have defined these three levels of consequence. But interestingly, and that is the first feature that we are going to bring out, is that this consequence is not in terms of lives at risk or potential environmental damage. It is clearly in terms of cost or cost ratios. So the three consequences of failure are given in terms of the ratio of construction cost plus failure cost normalized by the construction cost. And apparently the range is from 2 to 10. It is claimed, or it seems that if the failure cost is of the same order as the construction cost, then the consequence of failure for such a structure would be minor. And for large consequences, the failure cost is about 9 or 10 times at most of the construction cost. So it could be that more consequential structures or facilities are not being considered here. But again, the point to note is that any effect of lives lost or any effect of pollution is not considered directly, explicitly, but presumably indirectly through cost. The cost implication would presumably consider such losses, which would take the form of compensations, legal fees, and so on. The other feature that we would like to point out is we saw in the last two examples at least that the nature of failure or the availability of warning is an important consideration in deciding the target reliability. Here, however, we do not see something like that, but rather the degree of freedom has become the relative cost of safety measure. And three levels have been considered: small, normal, and large. And here is one example of a structure having a large cost, or a relatively large cost of a safety measure, and that would be could be because of high uncertainties, because of high obsolescence rate, or a short life, or an existing structure in need of repair and retrofit. So this is indeed interesting, because we see that the target reliabilities are higher for lower relative cost of safety measures. So and this is something that we have seen with lack of warning or lack of redundancy in the earlier codes. So can we conclude that lower relative cost of safety measure is in some sense equivalent to less redundancy at least if we have to be consistent with the earlier codes. So this was all from JCSS, and now let us put side by side the values proposed by the 1998 edition of ISO 2394. We are going to see later the 2015 edition of ISO 2394, which has certain differences from this revision. But if we have to compare the values of JCSS for the same three relative cost measures, but for the same, and also for the same three levels of consequence, you will see them in the red within parentheses. However, I should mention that this 2394 does not explicitly define what the consequences are. They're just listed as minor, moderate, and large. In fact, there is an even lower consequence than minor. So these numbers more or less match. We could see that for moderate and large consequences, the ISO standard proposes a little higher reliability, but they're more or less in the same ballpark. Now we are going to look next at the EN 1990, the structural Eurocodes that came out in 2002 around the same time, and how these numbers compare with those of the Eurocodes. And in particular, we are going to compare this normal relative cost of safety measure for the three consequences. So let us look at the structural Eurocodes next. We have seen this before when we were discussing the structure and philosophy of reliability-based design codes. So as you remember, EN 1990 has defined three consequence classes, 1, 2, and 3, and defined them and given examples of such buildings as well, or such structures. So for consequence class 1, it's low consequence for loss of human life, typically unoccupied buildings, and also environmental consequences are small or negligible. So we see some consistency or some continuity with the earlier codes like CSA and DNV that I already discussed. In the next consequence class, CC2, we have medium consequence for human life and considerable potential of environmental damage. And an example is given. So this would be an office building or a residential building. So this probably would be the most commonly occurring consequence class. And then high consequence class, CC3, is for high consequence for loss of human life and very great potential of economic, social, or environmental harm. And these are major infrastructural facilities, and you see certain examples in the right column. Now how, and then compared to these three consequence classes, three reliability classes have been defined, which are RC1, RC2, and RC3, and the 1 year target beta values are given, as you can see, starting from 4.2 for the lowest consequence class to 5.2 for the highest consequence class for a 1 year reference period. Now let us compare them with the set that we decided we looked at before in the previous ISO 2394. Here we are looking at normal relative cost of safety measures, and for again the three consequences which presumably would match CC1, CC2, and CC3, and the values are 3.5, 4.1, and 4.7, compared to 4.2, 4.7, and 5.2 respectively. So these are actually not small differences. If one converts these to PF numbers, then this would be quite a noticeable and significant difference. Now, it's quite possible that the beta values for EN 1990 are higher simply because life safety has been considered explicitly, and which presumably was not done in the JCSS and ISO 2394 documents.